Yesterday we started talking about the ratios of side lengths in what kind of triangles? Right triangles. So what we're learning about today only applies to right triangles. Okay. We are going to learn how to write, different kind of write, how to write the trig ratios for a right triangle. Okay. Now the three trigonometric ratios we learned yesterday were sine, you don't need to write these down, cosine, and tangent. Okay. Now, from what we did yesterday, right? Sine, cosine, and tangent. If I have a triangle where the angles are the same, what do we know about the sine ratio in those two triangles? They're the same. Okay. If I have a triangle where two angles are the same, but the sides are different, what do we know about the cosine ratio? Nope. It's the same. Right? Remember yesterday's worksheet? All the ratios were the same the whole time. Didn't matter if it was a big triangle or a little triangle. Because the angles were the same, all the ratios were the same. Same thing with tangent. If the angles are the same, doesn't matter what the side lengths are or not. If it's a right triangle, the tangent of an angle will be the same in both. The ratio is the same. That's why it was a constant ratio. So these constant ratios, sine, cosine, and tangents, have a set formula for each. And that's what we're learning today, is that formula. Right? So sine of theta. Now before we get going, S-I-N-C-O-S-T-A-N. S-I-N is not sin. It's an abbreviation for sine. Sine. Okay, not sin. Okay.
Cos.
Not cos. Cosine.
Cos.
Okay. Not tan.
Tangent.
Tangent. That's when I struggle with the most. I always say tan, but it's tangent. Okay? These are abbreviations for these words. Okay? They're not their own words. Okay? They're abbreviations. The reason I want you to use the right word is that way you sound more intelligent. Okay? When you're in a college class and you say, hey, professor, what's the cost of 30? They're not going to know what you're asking. You're asking for the cost of 30 books, or you're asking for the cosine of the 30-degree angle. Right? Does that make sense? Okay, that's expected then. Alexa, get a question?
I was going to ask you what do those mean, because I wasn't here yesterday.
We're going to hit them right now. Okay? All right. They're all ratios, though. They're ratios of side lengths. Okay? So like this is our triangle. Sine, cosine, and tangent are ratios of how these side lengths are compared to each other. All right, we'll get into them all. All right? So, sine. Does anyone remember from yesterday what sine was?
Say your name.
Wait.
It was y over r.
Opposite over hypotenuse.
Good. Sine is opposites over hypotenuse.
Mister.
What's cosine? Yes.
Adjacent over hypotenuse.
Good. Cosine was adjacent. Oh, no. Over hypotenuse. So those lines mean division, guys. Okay, so opposite over hypotenuse means opposite divided by hypotenuse. Okay. Adjacent over hypotenuse means adjacent divided by hypotenuse. And what was tangent?
Opposite over adjacent.
Yep. So it's opposite divided by adjacent. Here's two more papers, just in case. I have no idea. Okay. All right. Any questions about those formulas?
Are we gonna have to memorize this, or
No.
You will have to memorize it. The reason being is on the ACT, you will have to have it memorized. Okay?
Why?
Oh my god.
The plan test tomorrow, if this comes up, you might have to have it memorized. Okay? I don't know. Because it's just the way they say it. Alright? Guys, what's the question? Okay. So, these are the formulas for the constant ratio sine, and the constant ratio cosine, and the constant ratio tangent. Now, the formulas I found isn't the most difficult part for the student. It's figuring out which side is opposite our angle, which side is adjacent our angle, which side is the hypotenuse. Okay? So, here's our angle theta. Right? Remember, theta is a variable meaning angle measure. Right? So if I'm talking about the sine of theta, that means I want to know the sine of this angle So I'm looking for the opposite or the adjacent side, Austin. Looking for the opposite or adjacent side relative to this angle. All right, does that make sense? Okay. So sine of theta means what side is opposite this? All right, now we have three choices. We have the diagonal side, we have the vertical side, and we have the horizontal side. So don't shout it out, just think. What does opposite mean? Which side is opposite? Opposite means across the triangle. Okay. So which one is opposite? Diagonal, vertical, or horizontal?
Vertical.
Vertical.
Good. Vertical is opposite. This side is opposite our angle. Now another way to remember opposite is it is the side that doesn't make the angle. So these two sides make my angle, right? Right? These two sides make my angle?
Yeah.
This side doesn't. It's the opposite. Now the other easy one to figure out is the hypotenuse.
Will it always be the opposite?
Yep. The side that doesn't make the angle is always the opposite side. Okay. Now the other easy one is the hypotenuse. The hypotenuse is always the what side?
The longest.
The longest side. It's always across from which angle? The right angle. So hypotenuse is always across from the box angle, the right angle. Right? It's always the longest side. So this side right here, this is the hypotenuse. Okay. And I have three choices, so that means the last side is what? Adjacent. This side is adjacent. The reason why this side is adjacent is because it is next to the angle, which is what adjacent means. It is next to the angle, and it's not the hypotenuse. Did I?
With
A-D-J-A-C-E-N-T.
It looks like.
Alright. Any questions? So you're probably thinking this to yourself, what does this all mean? Wonderful. Opposite, adjacent. What does it mean? Okay. Well, in triangles, typically we're given two sides, we're given three sides. We can find the third one if we need to. Let's say this is a 3, 4, 5 triangle. So 3, 4, 5. Does that work as a right triangle? Yeah, because 3 squared is 9.
Yeah.
4 squared is 16. 9 plus 16 is? 25. Does it square root of 25 5? Yeah, so that one works, doesn't it? Okay. So the ratio we're looking for here is the length, if we're doing sine, is the length of the opposite side divided by the hypotenuse. Length. Okay? So what's the length of the opposite side?
5.
Right here I'm at theta. What's the length of the opposite side?
Oh, 3.
5. So this ratio is 3 over 5. Okay. Does that make sense? Guys, does that make sense?
Yeah.
Okay. Cosine. Adjacent or hypotenuse. So which number is adjacent?
No one next to
That's
it.
fine.
Okay.
4.
4, right? 4 is adjacent, isn't it? Which one's the hypotenuse? 5. So the cosine ratio is 4 over 5. Okay. Tangent. Opposite over adjacent, right? Which one's opposite theta?
3.
3. Which one's adjacent to theta?
4.
4. So this ratio is 3 over 4.
They don't turn into like.
Nope. These could turn into decimals if we want them to, but it's fine to leave as fractions. Actually, I like the fractions better because it lets me see which side to use.
So basically, you just like take, like if you label it, if we're doing a problem, you just label it and you just copy it.
Yep. Figure out what they're asking for. Okay. All right. Any questions? All right. Now this says label hypotenuse opposite and adjacent sides in the triangle above. We did that. How would these labels change if theta changed the other angle? So that means if instead of focusing on this angle, I'm focusing on that angle. Okay? So I switch my theta to the other angle. You see that? Okay? So how does this change?
It doesn't.
Sure.
Except the opposite and the
So
adjacent, but the
no.
hypotenuse always has to be the longest.
Okay. Well, one thing that won't change is these lengths. Just because I move my angle doesn't mean my lengths are any different. Right?
Yeah.
But if this is theta, Which side is opposite theta now?
The bottom.
The 4. Right? This side is opposite now. Right? That side is opposite. Right? Which side is adjacent now?
Right. The top.
The 3. And the hypotenuse, like Jasmine said, the hypotenuse stays the same. So if we switch the other angle, the hypotenuse is still in the same spot because it's still the longest side, still across the right angle, but the opposite and the adjacent switch. Right? Is that what you said, Jasmine? Nice job. Any questions?
The hypotenuse will never switch, right?
Right.
Okay.
It's always the longest side. Alexis.
So it'll just be in one of those two spots.
Yep.
So we could.
Those are the lengths of the sides.
Oh wait, what we're doing the other day though?
Yeah, that's a squared plus b squared equals c squared.
Okay, but wouldn't it be like that though?
No, because we're talking about that works for these right triangles. Though. Like if you have let's say you have 3 and 4 and you need to find the other side, then you can do the a squared plus b squared equals c squared. Okay, is that what you're asking about?
Yeah.
Yeah.
Mr. Brent.
All right.
Mr. Brent.
What?
Could we remember that if the theta sign is on the bottom left, could we remember opposite adjacent there?
Yeah, but all the triangles won't be like this.
Oh,
Okay. Sometimes they'll be standing up. Sometimes they'll be flipped over. Sometimes the hypotenuse will be horizontal. Sometimes the hypotenuse will be vertical.
okay.
So they won't just look like that. Yes.
I know which one's adjacent, which one's the opposite.
Okay. Oh my God. Jamari, pay attention, please. So how do you know which one's adjacent, which one's opposite? Here's my angle, right? Opposite is the side that doesn't make the
Okay,
angle.
okay, now.
Okay? So here, opposite's the side that doesn't make the angle. And adjacent's the other one that's not that close. Just making sure, being thorough. Thank you, Serena. Enjoy your travels. Alright. To practice, I want you to try this. Sine of theta, cosine theta, and tangent of theta. Try for this triangle right here, where theta's in a different spot. Alright? I want you to find sine, cosine, and tangent. Huh? All you need is right here now.
Yeah, you really need notes. Oh, never mind. So
What's those letters?
Sine.
So,
Sine.
sine theta is always gonna be like the hypotenuse and opposite. Okay, it's not gonna be like opposite adjacent. Okay.
What is theta stand for? Theta is just a Greek letter meaning.
Isn't that used for like
Sorority, fraternities.
Alpha Sigma probably. What's that one movie? What? Oh, grown ups, yeah.
You don't have to do it today.
It's Mario.
You can just look at
Right.
the
Have you seen commercials for that one new
Neighbors?
Yeah. That
one
one looks so fun.
I know. I can't wait to see
They throw the ball at him and just.
Alright, sounds like we're done.
You
So-
talking about the one where the people move into the
Sine theta!
I want to do
Gentlemen, sine theta is opposite over hypotenuse, right?
that. Yeah.
What's opposite theta?
4.
4. What's hypotenuse?
5.
5.
And then it's
Cosine theta is adjacent over hypotenuse. What's adjacent?
3 over 4.
3. Not 4.
Jason.
5 over 5.
3 over 5. Okay, good.
And I want it's
Hold on.
4 over 3.
Tangents.
4 to
Tangent is opposite over adjacent, so opposite is
4 to
4
adjacent is
5.
Do you have that? Yeah.
What?
Do you have an improper fraction?
Yep.
Begin.
That's fine. Okay. Are there any questions? Yes.
So it wouldn't change anything because the tangent is 4 over 3?
No. It's a different angle now.
I know.
Okay? No, it's fine. We have 4 over 3. It's okay.
Okay.
All right. So remember yesterday, guys, I said the sine of the theta doesn't change?
Yeah.
As long as the what doesn't change?
Angle?
The angle. Did we change the angle?
Yeah.
Yeah. And that's why our sine of thetas are different. Okay, does that make sense? Okay. Now, another thing we should take note of. This angle theta and this angle theta, they're the two angles in the same right triangle, right?
Yeah.
So that means those two angles add 90, which means they're called complementary. Okay? So these two angles right here are complementary. Now, something to note is the sine and the cosine of complementary angles are equal. The sine and cosine of complementary angles are equal. Okay? And the tangents of complementary angles are reciprocals. I know what you meant by opposite, but the math word is reciprocal. Right? You guys see that? So the fact that we're getting things that look like they're repeating, that's okay. Right? There's only 3 options for side lengths. Right? We're going to get some overlap.
Wait, you said the only time it would be the same is if
If these two are complementary, meaning they add to 90. So like this one, like this is 30 and this is 60. 30 plus 60 makes 90. So the sine of 30 always equals the cosine of 60. Alexis? Yeah, fine. All right. Now one more thing before we move on to our acronym and our example. All right.
you have a 45 and a 45?
Yep. Okay. Now, sine, cosine, tangent. Let's take a look at these real quick. Question I want to ask is, will sine ever be bigger than 1? Don't shout out your answer. I want you to think. Okay? Don't shout out your first inclination. Take a look at what you have and think about it. Will sine of theta ever be larger than 1? Okay, don't shout anything out. Just think. You have an answer? Raise your hand. Okay. Austin, I think you're first. Will sine ever be bigger than 1?
No.
No, why not?
Because the hypotenuse is bigger than the opposite.
Perfect. Hypotenuse is by definition the largest side, right?
Yes.
So this ratio will always be less than 1. So regardless, you can write down here underneath the triangle if you don't have room right here. So you don't have room right here, write it over here, that's fine. All right. Sine of theta will always be less than 1. Okay. Same question, but for cosine. Don't shout the answer out. Will cosine ever be larger than 1? Don't shout it out, just think. Cosine. Okay, Jamari, what do you think?
No.
No! Why not, Jamari?
Hypotenuse is the biggest side, longest side,
And it's on the
bottom.
bottom, good. The hypotenuse is the longest side, and it's on the bottom. So cosine of theta will never be larger than 1. What about tangent?
Yes. Oh, sorry.
Jasmine,
Yes.
it can be bigger than 1?
Yes.
Is it always bigger than 1?
No.
No. Tangent can be any number. Okay? Because it all depends on the relationship between opposite and adjacent. Sometimes it's less than 1. Sometimes it's more than 1.
So what do you put?
Tangent can be any number. Okay? Tan of theta can be anything. Okay. Using my poor handwriting there. Kind of hard to write below your waist. All right, any questions? Like I said earlier, you will need to memorize this. You need to know this. Okay? These 3 ratios, you need to have them memorized. Right? Now, don't get all nervous about it. There's an easy way to remember it. And now that summer's coming up, it will make some sense too. Alright? So let's say I want to go swimming. There's no song. It's not like the quadratic formula. Okay? Now let's say I want to go swimming, right?
Sure.
I want to see if the pool is warm enough to go swimming in. Or if the lake is warm enough to go swimming in. So you dip in your toe. So soak my toa. Soak my toa. Soak my toa. Get it? Soak my toa. Right, soak my toa.
There's no mom.
And I add.
Soka-toa.
Okay. Or soak a toe. See if the pool's warm enough, soak a toe, right? Put your toe in the water.
Soka-toa.
That's the worst thing.
Wow.
Yeah, I usually just jump in too.
Soka-toa.
Alright, so this is an acronym, a mnemonic device for remembering what SOHCAHTOA means, or what sine means, cosine means, and tangent means. Alright? So, it all depends on the first letter of the words. So, S is sine.
Oh, I'm smart.
Right? What's O?
Opposite.
Opposites.
Hypotenuse.
Okay, what is H? Hypotenuse. Good. Wait for the question, please.
Who said hippopotamus?
Okay. So sine is opposite. Sine is S. O is opposite. H is hypotenuse. And what so means is sine of theta equals opposite over hypotenuse. That's what so means. Okay. You write a backwards S, then a frontwards S. Okay. You write backwards S, frontwards S.
I never learned it like that. I just did it.
No.
What's C stand for?
Cosine.
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 What's A stand for?
Adjacent.
Adjacent. What's H? Hypotenuse.
Hypo.
Okay. So, what Ca means, C-A-H, what that means is that cosine theta equals adjacent over hypotenuse. Okay.
No. We got the theta.
Okay. And TOA. What does TOA mean?
Tangent.
Okay. T is tangent. O is
Opposite.
opposite. A is
Adjacent.
adjacent. So this means that tangent of theta equals opposite
Yeah,
over adjacent.
Mr. Branch, can you just look at the last two letters and just do
Okay. Now, if you have a hard time remembering what the formula is, Alexis, write SOHCAHTOA down on your paper. Okay? So when we flip over to the examples on the next page, first thing you should do, find an open spot and write SOHCAHTOA down. Okay, it can be at the top, it can be on the left side, it can be on the right side, it can be on the bottom. Just write it down.
SOHCAHTOA sounds like a volcano.
It will help you.
It does.
Yeah.
You know that episode of SpongeBob when they all have like weird powers? It's like crap.
Oh yeah.
I think it sounds like the volcano in Finding Nemo.
Oh yeah.
They have a name.
Yeah, what's that? He's like, and they start chanting it.
And they start saying shark bait. Wow.
No, and then he's singing something.
Alright, guys.
What did he say, Jamie?
Somebody's good.
No. Alright. Example 4, 5, and 6. Now, I have A, B, C, and D cut off the top right now. We'll come back to it in a second. But we're going to focus on D. Okay? We'll start at the end and work our way back.
Hey, Branch, look, somebody's really good at drawing.
Nice.
He just said A.
Alright.
Make him do mental stuff.
Okay. So we're going to focus on part D. Right? Now, the way I had this set up before the internet didn't work for us, is I was going to have a slide just for sine, just for cosine, just for tangent. We do just sine, just cosine, just tangent. Right? But I think you guys can handle all three at the same time. That's what we're going to be expected to do anyway. Alright? So being able to go back and forth between sine, cosine, tangent, that's something you need to know how to do. Alright, so let's look at D. X is right here. Y is right here, right? Oh, forgot to write down my acronym. So, TOA. Okay. There's my acronym. SOHCAHTOA. Help me out. Alright, so I want to find the sine of X, right? Here's X. Here's X. Right? I'm going to do sine of X. Sine is opposite over sine opposite hypotenuse. Right? So what's opposite X?
Y.
No, those are angles on different sides. 2.3.
Opposite.
So it's 2.3. What's the hypotenuse?
7.2.
7.2 because it's across the right angle. Oh, that's
Wait, we're doing-
sorry.
Yeah,
What?
we're doing D.
Sorry about that, guys. So, sine of X in D is 2.3 divided by 7.2.
Wait, why are we doing D?
Because that way you can see it all on one page versus having it broken down.
How do you
You got it?
no? How did you get to 7.2 right there? Like, why'd you choose
Why did you choose what?
7.2 right there?
7.2? Because 7.2 is the hypotenuse.
Oh,
It's the
yeah.
longest side, right?
Yeah.
It's across from the right angle.
So, because it says so.
Yep,
so
opposite over hypotenuse.
Wait, so which one?
Oh, it's always the last two
Yep.
that go together.
Just know, S is sine, sine opposite hypotenuse. Okay? Cosine adjacent hypotenuse. Tangent opposite adjacent.
Oh, okay. I got
Okay.
it. Yeah.
So the 2.3 is the opposite?
Yep, it's opposite ends. Alright. Try sine Y real quick on your own. Jasmine. Stop talking to Alexis. Try sine Y.
I'm right here.
Try sine Y.
What?
Try sine Y.
I know.
Here's Y.
Opposite over hypotenuse. We go on if we want.
Want to, yeah. Try all of these first then, because I'll be filling those in first.
Okay.
Alright, what's sine of Y for D?
6.8.
Oh, wait.
So here's Y, right? What's opposite Y?
6.8.
6.8, right?
Wait, great.
Yeah.
What's opposite Y is 6.8. What's the hypotenuse?
7.2.
7.2.
Oh yeah.
So you get 6.8
Oh, I see.
divided by 7.2.
Divide.
That's what the formula says. Alright. Cosine. Cosine, cosine is adjacent over hypotenuse, right? So, here's X.
I did physics and science.
Guys, here's X, right? What's adjacent to X? 6.8, right?
Yeah.
What's the hypotenuse?
7.2.
7.2. So cosine is 6.8 divided by 7.2. Okay. We did just do that one. Do you know why?
Yes.
Because X and Y are complementary. So the sine of Y equals the cosine of X. Nope, that's the tangent part. Okay. All right, try cosine Y. Try cosine Y.
Why don't you teach it like this?
In physics, you're supposed to already know this.
But I didn't.
Because you're advanced in just one subject area. You should be advanced in every subject.
I used to be.
Oh
All right, so it's cosine Y.
2.3 over something.
Good. 2.3
7.2.
divided by 7.2.
This is coming.
We just did that one too.
Oh my gosh, so we did.
Because sine and cosine for complementary angles are equal. All right. Tan of X. TOA. Tan is opposite over adjacent. Right? So what's opposite X? 2.3. What's adjacent?
6.8.
6.8. So this is 2.3 divided by 6.8. So try tan Y. Try tanny.
No.
Tan Y.
I get it, right?
My goodness.
Don't use tan, but I'm gonna say tanny.
It was a joke. Okay. So tangent Y, what is it?
Cosine.
2.8 to
Yeah.
3.
Okay, good. Alright. I want you guys to try the rest of these.
Oh, jeez.
Alright? So try the rest.
No, Branch, please, no.
Still gonna record.
Branch, jeez. Oh, Branch, I got my